So for 1.6, here's some of my thoughts on some of those homework problems. Here we are to use the graph, that one is shown above, to identify the x and y intercepts of the graph. Note the scale on the axis, blah, blah, blah. So we'll look. So remember what an x and y intercept are. An x-intercept is really just a dot, and that's why in the answer blank they have these coordinate-looking things. And so an x-intercept is a dot where we hit the x-line, or the x-axis. And so if this is the x-axis going across the page here, then we're just going to look for the dot where our line, curve, or whatever it is, hits that x-axis, and we'll describe the dot. Looks like we found one. So then wherever that hits the dot, or the x-axis, we'll describe that dot, and we're good. So looking at it, I don't know, let's see here. Okay, if this is a 4, see, it's all like in between, so you got to figure out what that is. So if this is a 4, it looks like these lines are skipping by like 2, 4, 6, 8, 10. So this thing's in between 8 and 10, so we can probably say it's just at 9. So it's 9 steps over, and that's on the left and right. So remember, if it's left and right, that's an x value thing. So we'll say that the x part is 9, and it is no steps up. It's not up at all, and it's not down there. And so if it's not up on the positive side, and it's not down on the negative side, but rather right in the middle on the x line, the y value is always going to be 0. And that's why they gave you that part, because that's part of what it means to have an x-intercept, is that the y value is 0, because you're not up and you're not down, you're right on the x line. Anyway, so this one looks like it's at 9, 0. So we'll say x-intercept 9, 0. Now y-intercept will be the other situation. We have a 0 and then something else. So let's see what that looks like. Other situation means our x value is going to be 0, so we're not to the left and we're not to the right. We're right down the middle on the y-axis, and we'll just see where we run into that line. So for our y-intercept, yes, indeed, the x value is 0, but how high up is it? That'll be the y part. So the x value is 0, it's not left and it's not right, it's in the middle. But the y part, let's see here, 2, 4, 6, 8, still works. 10, 12, 14, 16, so this is like 15, I guess, if I put it like more honestly in the middle like they had it. So it looks like 15 there, and that's what our intercepts look like, 9, 0, and 0, 15. Or just 9 and 15 is what they're looking for. What else? On this next one, we have to draw it ourselves. We're given an equation that describes a function, a linear function in this case, and we got to complete the table by shooting some zeros in there, or in other words, we're finding intercepts here again, and then we'll plot the dots on the graph and then connect them, so negative 5x minus 4y. If we shoot a 0 in for y first, as they suggested, let's do that. Minus 5x, take away 4y, so we'll shoot a 0 in for y, and we'll see what happens. So that's negative 5x minus 4 times the y value, which we're going to put 0 for, equals 20. And then 4 times 0 is easy enough, so we have 5x negative 5x minus basically nothing, equals 20. And then from there, we're just going to solve it out. Now, minus 0, you can feel free to plus 0 to both sides, or else just forget about it. I mean, just 0. But if you like to, you can plus 0 to both sides, and then 20 plus 0 will still be 20. Whatever, how you like that. But now we have negative 5x equals 20. Negative 5 times something is 20. I'm thinking it's negative 4. Or else feel free to divide it if you want to go old-fashioned algebra, and we can divide both sides by negative 5. Now we got just x equals 20 divided by negative 5 is negative 4. Looking good. So that intercept we have is at negative 4, 0. And then the next one, we'll plug in a 0 for x, and then let the y handle it. So this time we'll put a 0 in for the x part instead of the y part. So it's negative 5x will be, whoa, come on camera. Negative 5x will be negative 5 times 0 minus 4y equals 20. Negative 5 times 0 is still 0, minus 4y equals 20. And again, it's like you can get rid of the 0 if you like, or else just forget. I mean, who needs 0? And then negative 4 times something is negative 20 if you want to divide that out, or if you just want to figure it out. Looks like we're dealing with a negative 5. So the y part must be negative 5. Now we got a couple of dots here. This is not only an x and y table, but it's also coordinates, for us to find. And so negative 4, 0 is our first find, so we'll go negative 4 on the x part, and then nothing for y. So negative 4 on the x part, nothing for y. Negative 4 on the x part, don't do anything for y, so we're not going to go up, we're not going to go down, we'll just stay in a 0. And then 0, -5 will be I don't do anything for the x parts. There's no left and right part. I won't go left and I won't go right because it's not anything x, it's nothing x, it's 0x. And then the y part is -5, so that's 1, 2, 3, 4, 5 negative. We got ourselves a dot there. By the time we get those two dots, use the graphing tool to connect them. And we're as good as it goes. Boom. You could probably just use the line tool and not worry about putting the dots in the first place, but make sure that you make the line, but who cares, whatever. Anyway, make a line that goes through those things. Let me know if it gives you trouble on the computer. Anyway, that's what we're looking for. We got -4 and -5 are the stuff we're looking for, and then we draw it like such. Okay, what else? Oh yeah, this is a little bit weird. So there, the graph of this function, it's y equals -x squared plus 4x is shown. So we have a picture of it. It's this upside down parabola thing. We're supposed to use the graph to solve the equation -x squared plus 4x equals 0. So we could solve this algebraically, I guess, but they're asking us to do it by looking at the graph of the function. And so notice what's going on here is -4x, or -x squared plus 4x, that's the same thing as we were given as the function here. The only difference is we're saying, well, what if it equals 0? So in other words, they're replacing the y value with 0, and that tips us off about how this works. So -x squared plus 4x, we're wondering when it equals 0. In other words, when is it, what are the x values? Because that's what it means to solve this equation in this place. Is we're saying, like, can we solve this for x? Can we figure out what numbers to use for x, such that the y part can be replaced by a 0? Or where is it on this graph? If we're doing it by a graph, where is it? What are the x values that we can look at such that the y value is 0? So what that means for us, guys, is if we're looking for, like, where is it on this curve that this y value is 0? We just got to remember what it means to have a y value of 0. And a y value of 0 means it's not up here and it's not down there. It's in the middle. Because y values are the up and down part. And so if we have a y value that's not positive nor negative, it's not up nor down. So we're looking for, where is it on this graph that our y value of our curve is in the middle? And so you can see a couple of places where it does that. Right now I'm tracing the curve and I'm below the y line. I'm below it, below it, below it. Suddenly I'm above it. I must have crossed over. This is one of the places where our y value was 0, and now it's positive again. Now it's positive again, it's coming back down, and eventually we hit right back down on that 0 mark. So these are the two places, these two spots here, where our y value is 0, because it's not up here at 1, it's not up here at 2, it's down here at 0. And then we just got to describe that. And so we're trying to solve this out for x, so we actually have to describe what are the x values at these 2 points where that happens to the y value. And so this one, we know the y value is 0, but how far over is it? It's 1, 2, 3, 4. So in this case, the x part is 4. And then in the other case, the x part is, it looks like it's just also at 0. So the y value hits 0 when the x is also 0. So we got two answers at work here. We have x is 0 and x is 4 are the two x values where the y value of my curve came back down to the ground and hit 0. And so then you can just kind of like separate them with a comma. And so we have x is 0 and x is 4. So they'll just want you to put 0 and then 4. Something like that is all they'll be looking for. What else? What else? This is something that's a little bit new to 1.6 that we haven't seen. There's some stuff that's kind of review, and it's still weird, but this is something that we haven't seen until 1.6. And so we have this funny graph of a funny looking function, you know. And so it's asking us to describe it. Where is it increasing and where is it decreasing? And so we'll use intervals to describe it. And so when we say it's increasing on certain intervals, what that means is, as we trace this function, as we're going, imagine it's like a timeline or something, and we're going from left to right as time goes by. You know, if you're tracing your function from the left-hand side to the right-hand side, it seems like sometimes it is actually going up, and then other times it's going back down. So this function in particular looks like it starts out going downhill. You know, as we go across the timeline, it starts out going downhill, then it's back uphill, and then it's downhill again. And so we have to describe the intervals on which this thing is increasing. I see one interval where it's increasing. It's somewhere, it looks like around from here to about here. It seems like that's where it's increasing. And so what we'll describe is just the x values, the timeline part of it, between which this function is going up. And so if I look from here, describing it from left to right, I'm going, it looks like it starts out, it's between 2 and 3 negative here, is about the place where it starts to go up. And then it keeps on going up until we hit about there, which is at about 1 step over. And so we'll describe it as such. We'll say this thing is increasing from here to there, which is from basically negative 2.5 to about 1, I guess. And so we'll say that. On the interval negative 2.5, comma, over to 1, this thing is increasing. Notice how we're putting parentheses instead of brackets here. Because it's like it's not as though we don't hit that point negative 2.5 ever. It's not that. It's just that it's not increasing there yet. That's the place, that negative 2.5 spot. It seems to be, when I'm looking at it, that's the place where I'm not decreasing anymore, but I'm also not increasing yet. It seems like it's the place that's in between, and so we don't include those points when we're talking about this stuff, in a wavy-looking function like this. Okay. Decreasing on the intervals, that one's a little trickier because there's 2 places where it's decreasing. It seems like here we're decreasing everywhere to the left of that 2.5 spot. And so that goes on seemingly forever to the left. So you know what forever to the left means. It means we're going to go way out negative infinity, start at negative infinity, and go all the way until we hit negative 2. So from negative infinity all the way to negative 2, and a half, negative 2.5, that's where this thing is decreasing, from all the way over, all the way until we hit negative 2.5. So we'll put that first, from minus infinity all the way to 2.5 negative. Then we skip some stuff, and then we take off from here. And so it looks like from positive 1 all the way until forever to the right, I'm going to be decreasing again. So we go from positive 1 all the way till positive infinity there is also decreasing. And so let's do that. We'll go from 1 to infinity, also decreasing, and then we'll union them. You can use the little union button. They have a little shortcut button for it, else just a capital U, I think also works in my Open Math. Okay, or in Canvas or whatever we're using now. Then yes, I wanted to draw one of these with you real quick. So, sketch a graph of, this is number 16, sketch a graph of this mess. And so it's a piecewise function. We've talked a little bit about piecewise functions. Let's see if we can draw one. So this is a function that for the x values that are less than or equal to negative 2, the function value is equal to just this. And so remember, a function value or an f of x, that just means the y value for our purposes when we're talking graphs here. And so that means the y part is described as the following. And so we'll say the y part here is negative 3 on all of this part. So let's draw that part first. We say if the x part is less than or equal to negative 2, then the y part is just negative 3. And so let's find that on the graph. For the x parts that are less than or equal to negative 2, so we're looking like right around here. That's about the cutoff line. So here's the negative 2 line, and the y value is going to be negative 3. So it's 1, 2, 3. And that is for anything that is to the left of negative 2. So that's negative 3, negative 4, negative 5. That's what they mean when they say that. Less than negative 2. For the x value is less than negative 2, that's negative 4, or negative 3, negative 4, negative 5, until forever. Just don't forget it also has that equal to on there, right? And so, of course, we'll color in the dot because we're going to color in the places where, however I wanted to finish that sentence, something. And then, because of the equal to thing, and then we have this other weird part in the middle. This is the funkiest part because we got to remember how to draw a line. And so from negative 2 all the way until positive 1, inclusive of positive 1, we have to draw this line. It's the 2x plus 1 line. So remember what 2x plus 1 looks like. That's if you're going to only go like slope and intercept, mx plus b says it's 2 over 1 is the slope, and then plus 1. 1 is like the intercept. And so without a big review of that, remember how that goes is we'll say plus 1 means start up here at positive 1 on the y-line. And our slope is up 2 over 1 from there. And so we'll take that line and then up another 2 over 1. That'll give us a good idea about where to draw this line. And we'll say it is that line all the way from anywhere, x being from negative 2, where we left off from, all the way till positive 1, which is kind of where we stopped it already anyway, so we just won't go any further than that. And all the way down, we'll just keep that slope going straight until we hit the x is negative 2, which is cool, because they actually connect here, and that's neat. They don't always happen that way. And then finally, we have, if x is greater than 1, though, then the y value is going to be 2, or the function value is going to be 2. And so we say for x greater than 1, that's everything to the right of this 1 line. So here's the 1, and everything to the right of it is greater than it. Then the y value is going to be 2, positive 2. So we'll say, where's positive 2? That'll be up 1, up 2. So positive 2, anything greater than 1. So I'm going to circle that. The y value is just going to be 2 steps up. So we'll just go 2 steps up, and then we're going to shade to the right and say everything to the right of that 1 is also 2 steps up. This is 2 steps up. This is 2 steps up, 2 steps up, 2 steps up. Everywhere you look, it's 2 steps up. So it just becomes a line, and then forever out that way. Just remember, though, we don't have an equal to on that 1 here, so we're going to leave that an open circle. That's the kind of thing they're looking for. Theirs looks cooler than mine. Whatever. What else? What else? Looking good. Okay, let's do number 19. I didn't really want to, but I figured it would probably help you guys. You're going to get better at graphing these in 1.7 if we haven't done that yet. But let's look at it real quick. So if we wanted to graph this without any special tools, you might just start by doing an x and y line, you know, and we'll be like x plus 1, I'm sorry, the directions say graph the function, then identify the domain in interval notation. So we're going to graph it, and then we'll identify the domain. So to graph this thing, we normally like to plug stuff in to get a feel for it. So if I plugged in a 0, we're doing okay, I guess. 0 plus 1, because I like to start with 0, you know, 0 plus 1. If I plugged a 0 in there, 0 plus 1, and square rooted it, and then plus 3. 0 plus 1 is 1. So if I square root that, that's just the square root of 1 plus 3. But the square root of 1 is easy. Square root of 1 is 1. So this is just 1 plus 3. And 1 plus 3 is, of course, 4. So we plugged in a 0, we got ourselves out of 4. What I'm noticing about this is that since I have an x plus 1 in the square root, I think I could even get away with doing a negative 1. And watch what happens there. Negative 1 plus 1. That gives me really more like I get to square root of 0 all of a sudden. Because before I plugged in a 0, but I didn't get to square root of 0, you know? And so well, that's more of a 1.7 topic, but negative 1 plus 1 makes it like a 0 inside. So we're going to go negative 1 plus 1, and then plus 3. And so if you can find that spot, that the number that you can plug in, that would make this thing, that inside, to be like a 0, and you square root of 0, that tends to be the golden goose for us. So now negative 1 plus 1 is like a 0, and we're square rooting the 0 plus 3. 0 plus 3 is, of course, 3, and that's good. We got a couple of dots here. I'm going to put a star next to that one because it's going to be good for us. Beyond that, guys, we're going to have to choose our numbers careful because we have to do something plus 1 that I can square root, and then we'll plus 3 on it. The problem with plugging in like a 1 or a 2 is, like, say we did a 2. 2 plus 1 is 3. And I don't want to have to square root of 3. So let's just keep going. What if we tried a 3 in here? 3 plus 1 is 4. That'll square root. So let's try that. We'll put in a 3. Okay, so 3 plus 1 is 4. Square root of 4 is 2. So that'll be 2 plus 3. 2 plus 3 is 5. So we have 5 there. And then let's do maybe one more dot. We'll do one more dot, but then here's something interesting. Notice how I got away with negative 1, but I don't think I'll be able to get away with any more negatives here because I already kind of hit the limit on going into the 0 part, but you can't go into negatives. So if I'm looking for something plus 1 to square root, then we got that plus 3. Shoot. Oh, sorry. I'll put equals 5 from the last one. if I were to try and go more negative on it, if I was like -3 or -5, even -5, -5 plus 1 would be like -4, and 4 square root's well, but it would be a -4, so I can't really do that because square rooting negatives don't work well in the real numbers. So we're going to have to say that that place where we put a star on it and we were like -1, that's the number that when I shoot it in there, it makes it a 0 inside. That's probably as far negative as I can get right now. That being the case, let's get another one that square roots well. Let's see, we got 4 before, so let's see here, 9 square roots. So what if I plugged in an 8? And I do 8 plus 1 under the radical. 8 plus 1, yeah, let's try that. So if we do an 8, 8 plus 1 under the radical is like 9, so the square root of 9 is now 3. So then that's just, square root of 9 is 3, so 3 plus 3. So this is just 3 plus 3, or else it's just 6. And so now we have a 6 there, and this is enough for us to draw a graph. And so we have our points here. We have a 0, 4 point. Let's draw that. 0, 4 is 0, and then 4. We have a -1, 3 points, so that's -1, and then up 3. That's good. Couldn't go any more to the left than that, so I think that's as far left as it's going to go because of the negative issue, you know. And then 3, 5, 1, 2, 3, and then 1, 2, 3, 4, 5. And then finally, what do we have to do? It was 8. And so this only goes out to 7, so I won't be able to put that one. But it would be like 8 and then up to 6. And so somewhere around there, it looks like we got this function that looks something like this. Starts at the -1, +3 mark, because of our little 0 trick, and then it goes from there, and then that's the other thing. So now we got a picture of it, and they're asking us about the domain, and it looks like we kind of figured out the secret already, because the secret here is that the domain goes as far as -1, and then only to the right from there. So if we're to describe the domain, it looks like we're going to say I can hit -1, oops, infinity. I can hit -1. I'm going to do this somewhere we got room. The domain seems like we can hit -1, so on the left-hand side we got -1, and I'm going to put the box on it because we actually do hit the -1. Like you can plug in -1 without it being a problem.